Hey, my name is John Santaferraro, and this is the Digital Analyst, where AI makes sense and digital dominance begins.
The Digital Analyst with John Santaferraro, powered by Insight Jam.
Have you considered the potential for AI at the edge, where sensors are everywhere, devices are multiplying, and apps continue to rule the day? Think about the spread of video footage available around the planet and from the sky in the form of satellite imagery. Every electronic device and appliance is pumping out massive volumes of data ready for insight extraction and intelligence infusion. We've gone from distributed computing to distributed database to distributed applications and devices. At the same time, AI is exploding, with new applications for every category, subcategory, and micro business on the planet Earth. There's a huge opportunity today to connect the power of AI to the proliferation of edge sensors, apps, and devices. With all of this potential, there remains one big disconnect. How do you distill insight and artificial intelligence down to a size where it can be used at the edge? Add into the challenge that most applications at the edge interface with people, machines, or other devices. And because they operate at the edge, they need extremely low latency to be able to function intelligently, independent of the massive compute necessary to train models, analyze data, and deliver contextually aware insight right at the point of operation. This is especially important for high-risk applications like self-driving cars or intelligent drill heads. An intelligent drill bit operates at literally unfathomable depths. Today's offshore rigs are capable of drilling 250 miles from shore in waters that are up to 2 miles deep. That's 10,560 feet deep. Beyond that, they can drill to depths of 28,000 feet below the seafloor. How important is it to bring intelligence to that drill head and to extract intelligence from that drill head and avoid the mistake at that depth? I'm excited for today's discussion with Derek Collison, CEO of Synadia, and Justyna Bak, VP of Marketing. At Synadia, they have bridged the gap between AI and the edge, making it possible to deliver distributed intelligence and AI enable the edge. So grab a glass of wine or a cup of coffee and join me on my Tuscan farm in the hills between Florence and Lucca for the Digital Analyst. A big digital welcome to Derek Collison and Justyna Bak. It is so good to have you guys both on the Digital Analyst.
It's great to be here. Thanks for having us.
Yeah. Hey, listen, I want to jump right in. You guys are doing some really exciting things on the edge, the computing edge with devices and sensors and everything. And it's an area that is exploding. And the title of this episode is exploring the edge of AI, where AI meets the road. And it's just interesting to me that while the entire world focuses their attention on AI, you seem to be focusing all your attention on AI at the edge. How do these two worlds come together?
Yeah, I'll take a quick first pass and then we'll let Justyna kind of jump in. I think one, thank you for having us, obviously, but I think when we saw transition from server rooms to the cloud, right, or private data centers to the cloud, right, and all of the rules kind of changed, and you heard things like cloud data. Synadia was kind of, started as a company about 7 years ago, betting on the fact that edge computing would start dominating and that cloud computing would become kind of the new mainframe. It's not going away by any stretch, but most people would be interacting with edge-based technologies, and that the rules for those edge-based technologies would drastically change just as much as when we went from private data centers to cloud. And so when you hear Justyna talk about nomadic applications, what we're really trying to talk about is applications that could be self-sufficient, secure, have connectivity to the services and data that they need, but they can run in any cloud provider, any region, and at least for us, more importantly, make that transition to different levels of edge, right? So near, far, and beyond is a lot of times you'll hear us talk about that. Near is kind of the cloud providers themselves holding on for dear life, like Blockbuster. Far being kind of the traditional people that folks might know on this podcast, Akamai, Fastly, but also the new ones, right? Vercel, Dino Deploy, things like that. And then for us and our customers, especially early on with Synadia, when edge for them meant their own distribution center, their own factory, their own cafe, their own store, their satellite, their toothbrush, their electrical medical device, the rules were even more stark, right? You couldn't depend on everything that was built up around that cloud native. And so what Synadia was looking at is how can we use our core technology, right? That the NATS system to kind of bring together a promise of nomadic applications, even though when you look at the beginning of Synadia's journey, right, as a company starting a little bit over 7 years ago, we knew we would be misunderstood. We knew that we were going to start very differently than other folks. And by the way, it's not that we're necessarily smarter than anyone else. It's actually kind of the opposite. We just have experienced it. And me myself, I've designed systems where I started with a workload. And then, the next demo, I needed data. So I had to figure out the network. Then I had to figure out how to secure it, right? And so if you look at some of the natural players, and again, I'll throw myself under the bus here too with CloudFoundry, which is a system that me and a couple of guys from Google designed for VMware. A lot of times when you do it that way, right, you get these types of anomalies towards the end. So they're using federated architectures. A lot of times they depend on location dependence. They depend on security-based perimeter models. And what Synadia was banking on is that as edge continued to push the forefront and AI at the edge, which I'll allow Justyna to kind of elaborate here in just a second, is kind of one of the poster childs for that use case, that the rules were so different that we wanted to take a different approach where we thought about intelligent connectivity first with security built in right from the beginning. Then we layer data on top, and then finally workloads.
The next frontier of AI innovation is at the edge. There is no doubt about that, because that's where the data is, and that's where the AI-driven insight is critical to provide business value in different industries. And starting with the near edge, which is industrial manufacturing. If you can act on insights from the different parts of the machinery in real time, and you can optimize industrial processes, you can detect anomalies, you can improve productivity and efficiency, and in some cases, you can even keep the business operations up and running. Now, if you move further away from the edge, and one of my favorite examples is connected vehicles, like the electric cars today, they're becoming computers on wheels, with autonomous vehicles being the extreme use case where split-second decisions, mission critical, when a car needs to switch lanes, there is no time for delay. So it's not only impractical to do round trips to the cloud and rely on the cloud resources for these operations. It can be a matter of life and death in some situations. And you simply cannot achieve sub-second latencies if you rely on cloud resources. And then moving even further away from the cloud would be, for example, remote oil and gas operations, remote rigs, where you will encounter the harshest of the conditions on Earth for compute, where connectivity can be intermittent, latency will be high, there is not enough compute, and any troubleshooting operations that you would need to dispatch resources physically would be very, very difficult. So you really want workloads that run in these scenarios to be fully autonomous, to Derek's point, be self-healing, resilient. And so you need a different tech stack to operate at the edge. Edge native workloads need to be fully autonomous, and they have to survive in these hard conditions where they support mission critical operations. And I think 2025 will really be the year where, to your point, AI hits the road, the rubber hits the road. No pun intended for autonomous operations. But because I think we have achieved enough of innovation in the massive models that now it's time to shift focus to inference. And where the inference is happening, it's at the edge. That's where the data is, and that's where the real-time operations have to happen. I mean, the cost of achieving the level of intelligence in the model equal to OpenAI's O1 model in just 3 months have fell down, I believe, close to 30 times. So we're talking about orders of magnitude innovation just in a quick span of time. So I don't think we need to worry about training big models. I think we need to focus our efforts now on really extracting business value from all that AI innovation that you built over the years. And to Derek's point, you cannot forklift cloud applications and expect them to operate at the edge because it's just a very different environment. So that's why at Synadia, we really believe in the edge native tech stacks that really empower developers innovating at the edge to have everything they need to build apps that are truly resilient and truly delivering the results that we need.
Yeah, I love this example about the self-driving car. I actually have reframed it because as agentic AI becomes a big thing this year, the truth is that what self-driving car manufacturers have created is an AI agent that drives the car. It has to be able to do everything that a driver was. So it mimics all of the activities that somebody would do as a driver. But to be able to create the intelligence for a car to be able to drive itself, or for an AI agent driver to be able to drive a car, massive amounts of work were done in terms of creating worlds with synthetic data, worlds that didn't even exist, trying to mimic every possible scenario that could come up, every possible combination of scenarios that can come up. So there sits somewhere in a data center or somewhere in the cloud all of this intelligence. Do you have examples that would help our listeners understand how do you take sort of the PhD of intelligence that sits in the cloud or the data center and get it out to the edge so that these vehicles can actually drive? What are some other examples that help our listeners understand how all that works?
Well, I think, when we look at inference, right, at least Synadia took a view about a couple years ago that it would be its own kind of ecosystem. And it was kind of be divided into two parts that fit very well with Synadia's tech stack. One is prompt augmentation, right? Getting access to lots of different real-time data sources to augment a prompt, right? Um, and the second phase would be multiple models being utilized or agents, agentic AI. And what Synadia does very, very well at its base core connect everything mantra, right, is that it connects everything securely through location independence and what I call end-to-end communications. And I'll describe what that means. So for the listeners, you might imagine a world where the car is actually talking to a large LLM to kind of get an overall plan.
Mhm.
But then all of a sudden it's being augmented, the prompts are being augmented with both data in the vehicle, in the cloud. And then there's going to be models, lower end models that are still extremely sophisticated, vision models, things like that, running on the vehicle, right? And so the plan's coming from the cloud. Now all of a sudden the system is actually utilizing multiple models within the vehicle to kind of achieve its goal. And again, what Synadia does very, very well, that sounds very basic, is that it allows for true location independence and end-to-end communication, and then data and workload layers to be built on top of that. And believe it or not, with just those two little pillars, right, that we've been working on now for quite a long time, it provides a very powerful system. And so we don't necessarily change the what, we just change the how. And what I mean for the readers or the listeners is that the what is, oh, I've got to access microservices. I've got to access data, streaming data, event data, key value stores, object stores, things like that. But when you realize that the majority of modern distributed systems are built on location dependent one-to-one communications, unless unnatural acts are taken into account, which a lot of times these are provided for by the cloud providers where you don't have control of them, or you're not running them, you can control them, but they're there, like load balancers and GSLBs and Anycast and BGP and DNS tricks. All these types of things aren't needed with the Synadia tech stack. So you're still drawing the same diagrams on a whiteboard, right, to design out a system. It's just the how is fundamentally different, and it's kind of, for lack of a better word, batteries included for an application or a microservice invoking, let's say, AI inference at the edge to be able to run in a cloud, in a different cloud provider, a different region, at the base of a cell tower, and then actually part of it run inside of a vehicle where the moving pieces are moving around all the time and it doesn't care. It just says, I know I need to talk to a John. Please find one securely that I can trust, and hopefully it's the closest one to me. And you could imagine a world where, right, these models are starting to be loaded up in different locations. And so a very simple request would be, oh, I need to access a model that looks like this, right? And if there's one running in the vehicle, it immediately responds and says, I'm your person, I can help you out. But let's say it's running on cell towers, right, which is usually first point of contact outside of a vehicle for connected cars, or in the cloud. It shouldn't matter. And we believe deeply that these systems are not static anymore. They're extremely dynamic. And so data and services are moving around all the time. And that even makes the Synadia tech stack more valuable in those situations.
To Derek's point, you cannot forklift cloud apps to the edge and think they're gonna perform the same way. But cloud is still important, and definitely you want autonomous automations. To Derek's point, batteries included, offline operations, uninterrupted business operations by proxy. But then there is still a lot of value in moving the data to the cloud for deeper analysis and so training of the larger models. But I think really the future is more specialized models that are more purpose-built and that can operate in those constrained environments of a connected vehicle, for example. Since we are talking about this example, and where you really can make those mission critical decisions with real time data, no matter what external circumstances are. And modern vehicles are really computers on wheels. And there is a lot of innovation that is happening inside the vehicle to make the communication within the vehicles between the electric processing units within the vehicle more efficient. And sometimes, you don't need a round trip to the cloud. If you just collect information from the sensors to show it on the screen for the driver, like this is local information that should be processed locally. There's no need to send it to the cloud unless there is a value in using it for statistical modeling and to improve the performance of the future cars you would build.
Want more Insight Jam? Follow us on Instagram for exclusive content like a daily dose of best practices and buying advice from industry experts and leading solution providers. Or subscribe to our YouTube channel for long-form highlights from our expert panel discussions. The Solutions Review team is hard at work collecting the best enterprise technology information from around the globe, so don't miss out.
It seems like the edge is becoming even more important as AI explodes. It's a way potentially to operationalize the AI, to make it touch a machine, an application, a person, a device. And so it doesn't seem like it's going to, right now it feels a little bit niche, but it feels like it could also go mainstream. And we've had a look at some technologies like not virtual reality, but augmented reality and glasses and things like that. And there was a start-stop. And I think that was because we didn't have the richness of AI that was needed to augment reality. And we didn't have a means of actually getting something to the edge in a way that it was meaningful and relevant to the person who was wearing augmented reality glasses. So what do you think it is then that makes the edge so important in operationalizing AI? And do you think it's going to continue to get more important?
Yeah, I think we look at edge as in very simplistic terms, and Justyna knows this about me. I try to make things simple so I can understand them. But I really do believe if I'm in an elevator and someone's asking me what Synadia does, I said we provide technology and the ultimate goal of reducing latency to access data and services. That's it. And if they follow up, go and give me an example. It's like, imagine if you handed your credit card in a restaurant and it took an hour for them to process your credit card, right, to check out. Or for people like me, and maybe John, where we always had to go to the bank to deposit a check, or always had to go to the bank, right, to process things or do checks or whatever like that. I mean, it sounds kind of silly right now, but what I think we all could potentially agree upon is that the goal of us to always reduce latency to access services and data is always continuing, right? And now this frontier is we've got the vertical scaling, we've got the horizontal scaling, meaning we can make them faster either with vertical or horizontal. Chips have kind of come out of their, their doldrum of a while back where they were kind of stuck and are accelerating, but you still can't fix the speed of light. And so if all that processing power is all the way on the other end of the world relative to you, we call it tromboning, the experience won't be that great. And to Justina's point, it's not only just how you feel about it, if it's a person consuming the technology, but there's certain things and decisions that are being made, inside of vehicles or manufacturing plants and things like that, that have time envelopes, right? They have temporal semantics of, I need to make the decision within a time window. Otherwise it's either not good, meaning, it's bad, or the data might have changed enough where I'd have to reassess that, right? And so again, you're always trying to reduce that latency. And now what's happening is that you want to move said services and said data to the edge to reduce that. And so, I do believe we're going to see in 2025 a world of um, data sources running around that we're trying to access to prompt augment. And then even if, let's say, you're inside of a manufacturing facility or in a connected vehicle, I would imagine there's still going to be inference with LLMs, some running in the cloud that are very, very big and just need that, massive amount of compute still. But they're going to be interacting and talking and directing you to be using models that are local and using local data, right? That have these temporal semantics and these time windows. And so the way that we try to think about it is we're always trying to enact a technology that allows you to squeeze, the access time to data and services. And that's, again, by moving things around, but just moving things around isn't enough. It's this notion of everything has to be location independent. I don't know or care if
Very
John's running in the cloud, what cloud provider, what region, cell tower, or, oh, now he's running in the vehicle right next to me. And there might be a lot of Johns. I just want to pick the best one to answer my question, right? The other Johns might be busy, XYZ. And that just fits into that base tenet of, hey, if communications was intelligent and we define it as intelligent just by
Mhm.
saying it's location independent end to end, there's an incredible amount of power just in those two little things. They're very, very hard to get right, by the way. Don't get me wrong. This has been kind of a technology I've been working on for 30 years or so, to be honest with you, in some form or fashion. But when you kind of get it right and people kind of see it, they almost see it kind of like magic, if that makes sense. And again, they're not changing how they architect systems. They still have the moving boxes that make sense to them. But when they see it, and especially when we move assets around and the systems that are interacting with those never change, they never go down, they don't have to be reconfigured, you don't have to do an over there update. It just kind of works. A lot of our users and customers feel that feels like magic, which is a ultimate compliment in technology.
Reducing latency, but orders of magnitude definitely feels like magic. And we have several customers who are experiencing that benefit of using the Synadia edge native tech stack. Because ultimately, reducing latency allows you to accelerate inference at the edge, where the data is created, where it can be turned into business value. And one of customer examples I wanted to mention is a Norwegian company called Intellicy, and they build an ML platform to optimize industrial manufacturing processes. And before they went edge native with Synadia, they were experiencing latencies between 15 to 30 minutes, and they went from half an hour latency to less than 1 second by going edge native and fundamentally rethinking their messaging architecture and optimizing it for the edge and optimizing it for fast inference. And that has really helped them provide incredibly value adding solutions to their customers. Like, for instance, one of the major dairy producers in Norway, and I spent some time in Norway, so I know exactly what type of cheeses they are making very well. They have this incredible cheese in Norway called Brunost, like a kind of like very dark looking cheese that is made by this dairy company. And it's just hard to, it's a very delicate process. So like the right temperature, the right speed of each part of the manufacturing step is very important. And by utilizing the real-time insights, they keep that process really optimized at all times. And so every batch of product that goes through the manufacturing process is just perfect because you can fine tune it any slight variation along the way by acting on the data in real time. And so it's So already a lot of companies are prioritizing inference at the edge, and reducing latency is a top technical priority. And I think we only gonna see more companies adopt that mindset. Industrial manufacturing is definitely one of the pioneers, just because they have so many sensors, so many sources of information, and for the longest time, a bunch of that information was not acted upon in real time. Last year, about a third of industrial manufacturers were already looking at edge computing and utilizing the data in real time. And in just 2 years, by end of 2027, that number is going to go to 64%. So it's going to more than double in just a couple of short years, just because there's so much value to extract from these investments, and going edge native, accelerating inference at the edge, and extracting value from all the investments and the breakthroughs, technological breakthroughs that we've done over the past years in AI. It's just becoming a business priority to a lot of customers that we talk to. We had the privilege to serve every day.
Tell me why NATs? Because I don't think, and Synadia, as far as I know, is based on NATs, and for our listeners, that's NATS, not GNATS. So why not Kafka? Kafka is real time. It's accepted, and wouldn't that be more interoperable if you use that and instead of a new messaging system? I just spoke with a with a company that is using NiFi to connect with the manufacturing floor in real time, to be able to bring AI, same exact story, to bring that to the edge. So what is it that requires a new messaging system?
Yeah, I mean, that's a great question. And NATS, for people that don't know about it, it might sound very new. It's actually older than Kafka, believe it or
Okay.
not. Yeah. It's been around longer than that, or about similar to the same time, right? So I started in 2010, I think, as the system for CloudFoundry, and it was specifically designed to do telemetry, eventing, querying, command and control, right? And it has this notion of persistent lists communications. And so when people say, why not Kafka? Kafka does a lot of things very, very well, but they were built for a very, very specific use case. And so when they try to force it into things like microservices and replace databases and things like that, I think that those efforts met with a little bit of resistance from the ecosystem, simply because it's a tool that's not necessarily built for that. And while manufacturing floors have a lot of compute these days, so do cell towers. When you get into vehicles, but even manufacturing floors, of setting up a whole container-based system and Kubernetes and running Java JVMs and things like that, with perimeter security models in all of these factory places, uh, people start to look for other solutions. And so when people see NATs, they're like, okay, so I can do general raw feeds, just publish, fire, and forget, is what we call raw feeds, telemetry, eventing, request reply. Meaning, again, when you ask a question of a lot of Johns, let's say, in a normal distributed system, there's a lot of unnatural acts that are underneath the covers that are trying to make that look transparent, right? Load balancers, TSLBs, all the tricks that we talked about earlier in the podcast. And with NATs, you don't have any of that. It's geo-aware. It does the load balancing for you. It just kind of works. And there's no reconfiguration. You're not stopping and starting things that are trying to interact with the system, saying, oh, now you need to know John moved over here. He's running in the vehicle now, so to speak. So that kind of all goes away, and people can see kind of the modern building blocks of distributed systems are all kind of taken care of by the Synadia tech stack, right? With those, and being able to mix and match the exact patterns that they need. So, for example, like people ask me, why not Kafka for microservices? And I don't think it's a good fit, but it's up to the audience to figure that out. But what resonates to me in my head when I was at Google was, Google does a lot of things to store data and things like that, but they do that after they get you your query response. They're not going to make you pay the latency hit of logging your request and then logging the response and doing all of that stuff. At least it's not in line. But Kafka forces you into that model, right? They don't have an off switch of saying, don't save this one, right? Whereas NATS does. NATS was actually built originally as what's called NATS core, which is a at most once fire and forget type of mechanism, which I built some of the most dependable, rock solid distributed systems on just that premise. But we knew that we wanted to add persistence, and that's our Jetstream technology. So if you ever hear Nats and Jetstream, Jetstream is how we do persistence on that intelligent communication layer. And for the audience, I think the key take-home points around our data layer is simply that we have both synchronous and asynchronous replication. So think digital twins, we call them mirrors, source muxing and demuxing, things like that. And then we have materialized views. So we have a basic persistence engine, but you can look at it like a Kafka channel. You can look at it like a key value store. You can look at it like an object store. And our key value store really kind of took us by surprise. We thought that some people who were, we call them nothing but nats, NBNs. And we have a lot of our customers that are just all in. They find that it radically simplifies their architectures, simplifies how they reason about security as they move across regions, cloud providers out to edge, and just reduces the number of moving parts that they actually, because I asked, and I'm good friends with Salvatore, who's the original author of Redis. I said, what's the attractiveness here? And they go, clustering, because the NAT servers can Lego brick themselves together into any complex topology that crosses the whole world, like our Synadia cloud service does. But they also like the fact that it had a persistent story, right? So in other words, and we had the async replicas. So we had all this clustering and persistent story that they felt was very, very compelling. Now, pardon me, that being said, they've said, but if you could do some things on the value side, how Redis understands the values a little bit more.
Yep.
So it looks more like Redis versus Memcache. We would love you to do that. And we have plans to do, the majority of what our customers have asked us for. So it's probably about 70% of kind of the main drivers of Redis. But for the audience, you can imagine a world where you come in and you go, okay, I've got to move an app to the edge. And now all of a sudden you're saying, well, we need Redis to run out there, and we need Kafka to run out there, and we need DNS to work out there transparently. Now we need load balancers, and we need, all this other stuff. A lot of our customers have said that feels like we could maybe get there, but it'll take us a lot longer than we would like. And it feels very brittle, meaning once we're done, kind of like the 90s, it's like, don't touch it, right? You're not allowed to touch the system. Whereas in this modern world, right, these systems are extremely fluid and dynamic by design. And so they kind of look at Synadia as, hey, would this accelerate our move to the edge, but also give us the ability to keep changing this system and have our security folks not just, beating us up left and right. What's at least surprised me, quite frankly, from our customers is that a lot of our customers that we've had for over a year or so, they then go back on their own and redo their cloud architecture to look exactly the same way. And they say, we're not going to move it out of the cloud, but now we can trivially move between regions. If for some reason we want to go from AWS to GCP or GCP to Azure or whatever that is, that's very trivial with a Synadia-based application platform versus kind of the traditional tools, right? Cloud providers have provided just amazing technology that's pushed everything forward, but they run a business, right? And they are very incentivized to kind of Hotel California. They want you to check in, but they don't want you to necessarily check out. And we understand that, but for the modern systems that we see our customers innovating around, we feel the ability to move things, services, data, have security that you can bank on, but don't force perimeter security models. You can work with them if you want, and a lot of companies still do. But think about our phones, right? If we pay our bill and we've got a little eSIM and it's on, we have a production phone, whether we're in a airplane, on the ground at our house, traveling in Europe, it doesn't matter. And I really do believe that these, nomadic applications that Justyna kind of talks about, that kind of encompasses all of the challenges that our users and customers are seeing, you know, we see something more like an eSIM, right? You have a credential that is tamper proof, it's guaranteed, and as long as you've paid your bill or whatever that is, that thing works wherever you are. You don't need VPNs and VPCs and firewalls and all this kind of stuff that a lot of enterprises have kind of built up.
It sounds like it's truly hybrid as well, and it has this ability to just replicate applications wherever you need the application to appear. It sounds a little bit like magic. Is that what you mean by nomadic applications? I mean, I've read about it, and I kind of get it. If you could explain that, I think that would be really helpful for listeners.
I'll give it a little bit of shot, but think of an application, right? And you're going to move it to an edge location, manufacturing or whatever. All of the umbilical cords to all of the data and services that it needs on a Synadia tech stack, right? That's all transparent, meaning there is no step two. You literally just run it however you want to run it, whether it's running on an ECU, system D, however you want to do that, and it will work with latency, but it'll work exactly the same in the vehicle as when it was running in the cloud. Whereas if it was a traditional cloud native type setup, it's like, oh, how do we mimic S3, and do we need MinIO now? And what about the HTTP load balancers and the API gateways and the service meshes? And what about Kubernetes and the perimeter security, all this stuff. And what then happens is kind of like a follow-on effect. So in other words, you say, John, the microservice is running very close to the user, but John depends on a key value that's over there. And in our world, you go, oh, just create a digital twin right next to John, the microservice. And you can imagine a world in Synadia's world where we use AI ourselves to predict, oh, we know if John moves over there that we need to create a digital twin of this data store, right? Because John accesses that all the time. The kicker is that is extremely fast and is totally transparent to everybody that's interacting with John. They never change. They never go down. They never have to be reconfigured. It's just, oh, wow, John answered me really, really quickly. And it's the fact that John moved to the vehicle and, there's a async self-healing key value store that's being kept up to date all the time for the subset of data that you need, John, the microservice, in the vehicle. And so that kind of power, I think, we call that the light bulb moment with a lot of our users and customers when it clicks for them, they go, now I get it. Now I understand what's going on.
Yeah, I'm not sure that most people, especially business leaders and even data leaders, understand how much work has to be done by the infrastructure architect and then the infrastructure engineers to be able to put together all of the pieces, and then to somehow try and take that to the edge and have to replicate that every time. And I think what you're telling me is you eliminate that.
Exactly. And I do want to make sure that the audience is aware that, security teams have a lot of power these days. And when you get them out of their comfort zone, they don't like that, right? So if they're like, oh, we've got, a firewall and we've got VPCs in the cloud and we've got WAFs and we've got XYZ, and someone says, oh, I'm taking that little John app that's running inside of all that stuff and moving it to the vehicle, you can imagine a security team going, okay, great. How are you going to secure it out there? Because all the stuff that's over here, you can't get access to, right? You can't just, to Justyna's point, move it with you. And so all of those little things that we talk about around security being built into the base communication layer on day one, we build upon that, right, as we go up the stack. And it's very purposeful that we did workloads last. But workloads is just a form of data or services or a combination of both that in our world you can transparently move around. And so you can imagine a world where John V2 all of a sudden gets shot into the vehicle and they say, hey, let's run 2 of these and then run 5% of the traffic through John V2 and see how it goes. And, I'm not saying it's totally impossible with traditional tech. It would just take a very long time and be, in my opinion, very, very brittle, meaning we finally got it running. And then someone says, oh yeah, we just got John V3. And they're like, well, that's going to be another 2 weeks, all right, to get that one updated. Whereas in our world, it's kind of click and it's done in seconds, which we believe the ecosystem is not only wanting, but demanding.
Solutions Review is inviting you to join InsightJam.com. What started a few years ago as a social media event to celebrate enterprise technology has now grown into an always-on tech community with live events, discussions, videos, vendor showcases, and industry resources. Our vetted roster of experts, thought leaders, and analysts are sharing tips and tricks daily. So if you're interested in getting involved, join the long list of companies and brands who have already participated by visiting InsightJam.com today.
I got to throw this out there, Derek. I think you'll get this. I wanted to figure out this whole agentic thing, so I started doing research all the way back to 1995 on agentic architectures. When agentic AI was first conceived, there wasn't compute power enough to do anything with it, but everything that we're doing today and seeing here in 2025 around agentic autonomy, be the ability to act, the ability to interact, to collaborate, to be able to adapt, learn, all of those things were conceived of in 1995. And the first real instantiation of agentic was actually distributed computing. And it sounds like with what you're describing that this may actually be the sort of the key to actually fully realizing the agentic future and agentic architectures.
Yeah, I mean, I think that's a great point, and you're right. I think the key distinctions that I would bring out though were those were location dependent. I had to know where you were, and it was always one to one, unless you did unnatural acts. And so I think that the explosion of these types of systems, whether you call them agentic AI or just the modernization of distributed systems, right, as they continue to grow and be pulled apart, right, these systems are becoming very sparse. They're becoming pulled apart. Those base tenants that we have in that base communication layer that's powered by NATs, they all of a sudden become more and more powerful, and people start to see the power of, oh, I don't need to know where John is, and I don't need to know how many Johns are running. I just need to ask John a question, and I get an answer that I can trust, so I know the security's in place, and I get it as fast as I possibly can, right? And again, we don't solve the vertical scaling, but we solve horizontal scaling and the reduction of latency to access, said John, because we can move John anywhere without those perimeter security models and those federated architectures.
I'm hoping that that when the John agent appears sometime in this year, because Sanjeev Mohan predicted that I would have my own personal agent by the end of the year, so I'm waiting for that, and I'm guessing it's going to have to run on Synadia and NATs to be able to go wherever I need him to go. But is this now sort of the end all to messaging? I mean, there's been an evolution, and even though this is, as you described, an older platform, you've modernized it with your Jetstream capabilities and persistent. You've got synchronous and asynchronous. So I'm guessing you can also do some things with data that other messaging platforms can't do because you've got both of those things in action, even probably things like change data capture for real-time data, which is not an easy thing to do. So with all of those things, do you think that maybe this is the end all to messaging systems?
Well, I think, you know, we're extremely proud of our technology, and we're extremely proud of our customer list. It's a proverbial who's who, you know, for the global 1,000, and in the United States, probably the Fortune 100. A lot of them don't allow us to talk about them. But what it gives us is it gives us a lot of different looks of how people are stressing the system and how they want to take advantage of the technologies that we provide, so that we know that it succeeds in a mission critical type of scenario. Because every customer that we have, this technology is mission critical, meaning if something's not working correctly, my phone blows up and the business stops, right? And so we take that very, very seriously. And a lot of the tech folks on Synadia come from Fin Services in the 90s, where we kind of get that. We understand, you know, with trading systems and things like that. Now that being said, you know, there's, you know, other technologies and you know, they look similar that are trying to solve these types of problems. Again, we're very proud of our tech, but I'm not saying that it will only be us, but I do believe that it would look something more like us versus what a traditional system is looking at, which is pretty much HTTP everywhere. And someone asked me the other day at a conference about HTTP, and I said, for last mile, I have no problem with it. But the metaphor that I would want to draw for the audience is it's kind of like your cellular provider, or let's say NVIDIA saying, yeah, we're going to hook up all our GPUs over Wi-Fi. And people would be like, yeah, exactly. Everyone laughs. And the whole audience laughed. And I said, you laughed, but you don't laugh at architectures that are HTTP last mile, gRPC, which is HTTP in the background, all using these unnatural acts to get around things like just traditional horizontal scaling, load balancing, things like that. And so we believe deeply that the core of these systems should not be HTTP or location dependent request reply semantics, right? It should be location independent and end to end by default. And you get a tremendous amount of power with that. Now, that being said, you know, we believe deeply that Synadia, if it was ultimately successful, would be a platform. And there's two flavors of companies that I think you see. One is that they want to become a platform company, but they design the solution first. They get good traction. Sometimes they succeed, but a lot of times they fail to make the transition to a platform, meaning the customers say, yeah, it solves this one problem, but then I run out of runway. You know what I mean? And now I'm waiting on you for 6 months to try to catch up. What we tried to do, you know, is make it a platform first. And now we're starting to build and curate solutions that are built on our core tech that are applicable to manufacturing, which is going through a renaissance, connected car, AI at the edge, entertainment, all kinds of different verticals. But that meant that we were going to be very misunderstood for, the first probably 3 or 4 years of our existence, which we were. But now we're starting to see, as we curate these solutions and talk more at the problem space that customers are facing, that it resonates. We get them in the door quicker. We get them to be successful quicker. But what is the most important is that they don't feel like they're running out of runway. So they go, hey, can we do this? And we're like, yep, you can absolutely do that. Oh, can we create a key value replica in a different cloud provider and then also have one at the edge and daisy chain them together? Yep, absolutely. And so I'm not saying, we've done everything perfectly. Nobody does, right? There's always bumps in the road, but we very strategically took that approach to do things in reverse order and to be misunderstood, make sure that we had a good box of Legos that people could build almost any modern distributed system that truly represented a nomadic system that could easily move between cloud providers, regions, and edge. But now we're trying to formulate some of those higher vertical solutions that will appeal to customers a little bit more.
So just a quick summary, and Justyna, maybe you go first. Where do you see this? Where's all this headed?
Yeah, well, just to recap what Derek said, it sounds almost too good to be true. It sounds like magic that on one hand, you're solving true application portability problem that we've been struggling to solve for years in computer science. And we're reducing that latency tax to Derek's point, and we allowing applications to run quickly and act on the insight that is generated at the edge. But at the same time, we can build systems that are extremely scalable. Like we have customers who send billions of messages per second, and then NATS is the backbone of some of the largest financial services processing companies. Yet it's so portable. And so just to recap, the three things that I personally really love about our edge native tech stack is that first of all, it's lightweight and simple. As the NAT server is less than 20 megabytes big in most cases, and it provides everything an AI app needs to thrive at the edge and be fully resilient, batteries included, and whatnot. It's also extremely versatile. So to Derek's point, the data persistency, you can use key values, you can use object storage, and the application will always be able to store the data and then sync it back to the cloud when connectivity comes back up. And finally, the system is very timeless. The system built with NATS, we've had customers who've had production use cases for years, and it's just working, because once you keep things really simple and lightweight and versatile and timeless, you adhere to these principles, you can build extremely complex systems without making things complicated. And the moment you make things complicated, there is a space for error. That's what by design is not what happens when you build with NATS. So where are we heading? I think we're going to accelerate innovation at the edge in 2025, and it's going to be a really fun year because we already seeing early examples of agentic AI among some of our most innovative customers. So we see small AI startups pop up and, for example, look at things that you really want to apply AI to, like, for instance, log analysis, and then creating an agentic network that discovers insights hidden in the logs and then acts on this information to build more resilient systems. I think it comes back to the original premise of AI when Gen AI revolution started in late 2022. I immediately thought to myself, well, AI is going to amplify our strengths and it's going to help overcome our weaknesses. And I think that agentic AI really plays to the latter because, once you solve the problem, the creative human being, you don't really want to spend time repeating the solutions and applying it over and over again. That's where computers come in. And that's where I see, the beauty of AI is to really capture the insight, classify information, provide the input for a business decision. And now agentic AI comes in to really execute on this in an automated fashion without leaving any area uncovered. And we're going to be seeing those first use cases in production of true agentic AI, I think, this year. And it's just a really exciting year to be in AI.
Fantastic. How about you, Any parting words for our listeners? Derek?
I do believe, I studied neural networks and AI in the mid 80s, right? And we went into the largest or second, the largest AI winter, but it was the second AI winter right when I graduated. And so it kind of stalled. But being in the industry now for, quite a long time, I've never seen a technology move this fast. And I've never seen what I thought was massive barriers be torn down so fast. In other words, the ability to access data, right? The compute needed to do that, the power to power all of that. All of these are, for the most part, on paper, solve problems, meaning they're not going to be road blockers. And so I think any type of software vendor has to understand that the ecosystem is looking for things that are extremely agile that you can deliver faster. And to Justina's point, are complex, but maybe not necessarily complicated. And again, our theme is that all of these things will always continue to push the envelope of reducing latency to access said services and data, meaning that we firmly believe edge will dominate, and it already kind of is, probably more so than people even realize today. They might think they're interacting with the cloud, but they're usually not. But for us, again, it's that edge of what is your edge? It's in your home, it's your factory, it's your car, whatever that is. We feel deeply that we can innovate and help refine what modern systems look like in those environments. So that's our goal.
Yeah, exciting, really exciting. I don't even need to go out on the edge to say this, that the edge is going to become increasingly important in 2025 and as we go into the future. And platforms like you guys have built and created and made concrete and enterprise ready, absolutely necessary. Thank you guys so much for joining me on the Digital Podcast.
John, thanks for having us. We really appreciate it.
Thank you for having us.
Thank you so much for joining this episode of The Digital Analyst. If you enjoyed what you heard, do me a favor, look down below. You can like and subscribe to the InsightJam.com YouTube channel. Make sure to check in on the playlist, The Digital Analyst. And if you want to connect with me, absolutely do connect with me on LinkedIn. I love to have dialogues, conversations. You can find out more about what I do at ferraroconsulting.com. If you want to connect with Derek or Justyna, you can find them at Synadia.com. That's Synadia.com. Thanks again. We will see you in a couple of weeks.
Powered by Insight Jam.